Hey, I'm Lorentz from iWood Cosplay, and today I'm going to show you guys how I made Mira's Glaive from the movie that needs no introduction. Okay, so by now there's plenty of great 3D files out there for Mira's Glaive and other K-pop demoners, but as a creator I wanted to create my own, and as someone that flies a lot, I need to be able to take it apart and put it in my carry-on. Here are the print files I designed for this project. Keep in mind the blue parts are intended to be printed in transparent PETG. Remember to change settings when switching to the gold PLA. If you want the gradient finish, then you'll have to follow the layout I just showed you. As for the gold, it's a pretty straightforward print job with supports at the base. Like most electronic projects, you'll need a soldering station and some trusty rosin paste. Links to all electronic components used in this project in the description. Here's the diagram of Mira's Glaive. We'll refer to this diagram throughout the build. Let's start with cutting our LED strips. We'll need 3 LED strips. First one will be 100 centimeters, 42 centimeters for the midsection, and 70 centimeters for the blade. Next, we'll cut our positive and negative wires. Following the diagram, measure the correct length for each. For the battery, we can carefully remove the blue wrap. We will be replacing the end with a female JST. The wire will be mechanically linked in this fashion. It's important to use the female JST in this port. The male JST will not fit securely. Eyeball the position of the splice points. Remove the JST and exposed wires at the splice points using a wire stripper. Do the same thing on the ground wire. Remove the battery and make a physical connection between the wires at the splice points. Apply rosin paste, then solder the connection like so. Now do the same thing to the ground wires. Clean up the joints with some isopropyl alcohol. Because we have exposed wires, you already know, we must cover them with some electrical tape. Now that we've safely covered them, we will put the battery back in the main handle cover. Insert the JST into its socket port. Next, we will connect the SPST. Eyeball the connection point and trim the positive wire. Expose the wire end for a connection point. At this point, it's helpful to have some soldering clamps to hold the SPST while you apply rosin paste to the connection point. Next, we will want to tin the ends by heating from the bottom and letting the solder settle on top. What is tinning, you ask? It's a process that preps the metal surface to create a clean and strong joint. If you're having a hard time soldering joints, try tinning. Once the wires are connected to the SPST, fit the SPST into its position like so. It's probably a good time to check our battery connection with a voltmeter. The readings are jumping because I couldn't get a stable connection, but I'm just checking to see if there's any output. Time to solder the LEDs. Line up the terminal ends and label them for your sanity. Then tin the copper pads. Solder the 32 cm wires to the 100 cm LED strip. For the 70 cm LED strip, if we want to be able to break down the glaive, then we will use these JST connections. Take the longer end. This wire should be around 14 centimeters. If not, you will need to extend the wire to ensure you have enough length for a proper connection. Solder the wires to the copper pads. Once you've done that, moving downstream the JST, we will need to extend the opposite end with the 52 centimeter wire. Cover the exposed wire with some shrink tubes. If you don't have shrink tubes, electrical tape works fine. Quick recap, we just joined the LED to the JST and extended it by 52 centimeters. Okay, so I'm gonna stop you guys right here. So the original design was to use T-spades to connect these wires so I can take apart the rod, but they weren't working the way I wanted them to. So this is why I have the DC connectors right here. You can also use JST connectors. You can use any connectors you want if you want to be able to take apart the electronics, but I'm just showing you guys the DC connectors right here. Time to assemble the first part of the rod. Take the pommel end and insert the carbon fiber rod into its socket. Super glue it to secure the connection. Then take the LED strip from segment A and begin wrapping it around the rod. For a compact wrap, we could have used another 10 or 20 centimeters, but it's not the end of the world. Because we were a little short, we had to increase the gaps between each band. Once we've done that, guide the wires through the LED tube. Some tweezers may help here. Take this handle cover we worked on earlier and eyeball a splice point. Before soldering the joints, I will test if the splice points and the battery are working. Looks like they are. Now is a good time to super glue the LED tubes to the pommel. So I'm gonna stop you guys right here. The spade connectors I was referring to earlier, you guys can see right here, they make this part a little difficult. If you're using the DC connectors, they are heavier, and with the help of gravity, they should be able to slide all the way through. So that shouldn't be an issue for you guys. You'll also notice a channel for the wires to run along. When the battery is fitted, the wires should run along the channel like this. Bear with me here, this is a messy part of this build. The goal here is to fit the battery into the main cover handle, super glue the JST into its port, and super glue the back of the SPST to its position. Next, we will join the ground and positive wires to splice points we made earlier. Cover the exposed wires. Secure the rod with super glue. Take the other main handle cover and super glue it into place. Make sure no wires are being pinched. Make sure to test the switch. Congrats, the hardest part is done. Lastly, super glue this detail, which is gold in the Mattel toys, but lights up in the show. I'm not doing that for this build. Like I said earlier, I initially went with the spade joints. Here I'll swap them out for the DC connectors. Before moving on, I'll just connect the DC ends and test the LEDs. They seem to be working. Time to connect our last LED strip. Take our short 3 cm wire and solder them to the copper pad of our last LED. Take our 52 cm wire and measure roughly 34 centimeters away from the DC connector and mark our splice point. We'll be making a T-split with our last LED strip. Expose the wires at our splice points. Carefully wrap the positive and negative ends of the wire to the splice points. Then solder the connection. Like always, wrap the exposed wires. For our sanity, let's check if the LEDs will power on. And it does. That's great. Let's move on. You probably don't want your rod to snap. You should enforce them with some carbon fiber rods, the same one we used for the bottom half. Following the diagram, we'll measure and cut 2 smaller sections that will go into the top handle and socket shaft. The uncut carbon fiber rod will go inside main handle 2. Make sure it's flushed at this end. Insert the DC connection end of our LED strip into the rod. Our splice point should be just outside the rod. Take this part and insert both the JST and LED strip into the center hole. Add super glue to both the cross section and rod, then join the 2 parts. Next, take this cylinder and slide the JST end through its center hole. Locate this trench on the cylinder. This will be the path for our LED strip. Secure the cylinder at the base with some super glue. Make sure not to pinch any of the wires. Then begin wrapping the LED strip around the cylinder. Add some super glue at the start. There's enough LED to tightly bind the cylinder. Next, put on the short LED tube, then super glue it at its base. Okay, so for the prototype, I use nylon threaded inserts, but the 3D printed files will work just fine. You will need carbon fiber rods though. All that's left is attaching this top part. Add super glue to the top of the LED tube. Guide the wires through the center hole and put the two pieces together. I used the super glue accelerator for the tutorial, but I actually recommend you don't use it if you need more time to position the parts. Congrats, you just finished segment B. So I know it's super tempting to super glue the blades together, but if you want to put the LED strip in here, we have to work starting from the tip. Grab the 70 centimeter LED strip and peel off the adhesive back. Push the LED strip as far as you can up along the spine. You'll need something thin like a ruler to press the LED strip against the spine of the blade. Apply some super glue at the front section of the LED just in case the adhesive back isn't strong enough. We'll repeat this process until we've joined all the seams. Okay, so for me, I had some gaps between these blades because I enabled raft support when printing them. So if you're listening and you don't want these gaps, just turn off raft, unless your printer is knocking these guys over. So once you have the blade made, attach this socket shaft with some super glue. Lastly, we'll attach this part of the socket shaft to the blade. I've designed a dovetail insert for your convenience and security. So the dovetail holds the blade pretty well, and I didn't show you this, but I would still use super glue for a permanent fix. All right, and that's it for this build. It's dark because my battery right here died. But if you guys want to support me in this channel, then you guys have links. There's links down below where you guys can get the files. I will be offering the printed kits as well for a limited time. So if you want to support me, again, the links down below. With that being said, much love, and I'll see you guys in the next one. Bye.